I bought this laptop. I'm just going to start with this story while I try to fix stuff, see if I can talk and do things at the same time. I bought this laptop about 3 months ago, and I thought, well, it's a Dell. It'll work with Linux, right? Sure. They have cool stuff like the XPS 13. Anyway, I was super, super, super wrong. So it was like a personal failure to not look into this thoroughly enough. And then when I contacted Dell support, and they were like, nah, we don't support that with Linux. It probably won't work ever. I was so angry, partly because Windows 10 was super failing me to let me do my job, that I was about to take this brand new laptop and just make it a paperweight somewhere. I was that mad. And then I got patient, though, after having a fit on Twitter, and Dell trying to apologize via DMs that they pretended to not have Linux support, and then finally sent me a link with some good references about how to make it actually work with the XPS 15. And after about 6 hours of tweaking, I finally got it to work. However, sometimes, like when I plug in projectors, which are very hard, it doesn't work. Or the second time it doesn't work. So, I think if I click... Okay, I think maybe we just get that view. New Firefox user, for many reasons. So it does different things for me. All right, what I'm actually talking about, which does include failure, is some architecture guidance around database reliability engineering and also doing development around databases. It's something that I find I keep doing a lot of work around because there's not actually all that much work done around it. It seems that a lot of database work, especially as things get bigger and bigger, is the artisanal, handcrafted, organic variety that if you turn one knob wrong, the whole system comes down and you get a very good story about failure. I'm trying to reduce that and make it a little bit more boring with a lot of the work that I've been doing lately. From that, all of this is from the perspective of using Go to do this work with, which I've been using a lot lately. And I have my top 3 reasons why I like Go for this work. The first one is one that I talk about all the time, and I feel like I'm screaming it all the time, and some people are like, well, maybe that's not that important, maybe it is, maybe it's not. I guess it depends on the scenario. Everything always depends, but one thing that I love about Go is I can build a binary and I can ship it to Windows, or I can ship it to Linux, or I can ship it to some other OS that like 4 people use. And by shipping that single binary, unlike if I write some database CLI app in Node.js, I don't have to ship all of NPM with it. Or if I use Java, I don't have to have the JVM on the machine, even though it's usually there. Just like Python has, it's installed on like every machine by default, practically. Some machines don't, though. So I like to be able to just ship the binary, the one single binary, and put it on the little bitty container or whatever it is that I'm trying to do something with, and it's done, right? So I can give that to a person that's responsible for that, and they have that one binary instead of an entire language ecosystem. So I love that about Go. The second thing is the ease in which I can get it parallel processing. Like who's written Go in here, by the way? All right, so who's written some Go routines? Yeah? Who has written C++ or C? Who has attempted to do threading in C, C++? Right, okay. I knew that would invoke that thought. Needless to say, Go is like exponentially easier to get some parallel processing going in code without having a lot of skeleton and ecosystem running around it. You can write a Go routine, you can spin it off 1,000 times, and it's running. I've built applications where it comes up frequently, like you got a database, and it has maybe some structure, maybe not some structure, but you want some data in it, right? Who's written something to generate data to stick in a database? Anybody? Yeah, it's a familiar problem. With Go, I can build a thing, grab a library to generate some data or whatever, and then stick it in a simple little for loop, say spin up 10,000 routines and start dumping it into this system. Works pretty good. And it's like a little blurb of code usually, instead of 9 pages of object orientation to manage where the thread might be or if something might fail and bring down the database. So that's a beautiful thing. And then, of course, by proxy of that, there's a lot of concurrency support in Go that helps in using that for this type of work. So that's why this whole talk is from the perspective of Go, because I'm using it, because I love these features, and I think that it helps us. If you use Go for your database reliability work, your CLI development, things like that, it helps you ship things to people who would use your CLIs and your applications and services in a much easier way than a lot of the existing language stacks. Not that I'm sworn off all the other language stacks. I love all of them. I love to nerd out on whatever, but Go is like my go-to these days. So in the language is great, and that's cool. It helps me build things around distributed databases, like doing backups and things like that with Postgres. But one thing I don't like to do is reinvent the wheel. Speaking of things that almost became failure, once I had this task. Somebody says, okay, we need you to do all this extraction, then we need you to transform some stuff, and then bring it into this other database over here, like all these steps. So I start working on this, and after working on it with myself, another person on the team, I think it took us about 2 months to really get it working. So we got it working, we're super stoked, and we're like, maybe we can build a tool around this. And we were using SQL Server, and that next day, Microsoft goes, oh yeah, check this out, this thing in DTS here, it just does this transformation stuff for you. Everything that we had just built, right there, deployed one day, boom. It's like, we just wasted I don't know how many thousands of dollars building all this stuff, and then they release a thing that basically does it. So I don't like to reinvent the wheel if I don't have to. I like to use the libraries and tools and fit things together and get the job done that way, if at all possible. If I have to build something, I will, not a problem. But it's nice to just, get things done and ship sometimes. So on that note, here are the tools that I've been using in the Go ecosystem to help build things around my database engineering efforts and such. The first thing, libraries around observability monitoring and insight. Who has read a bunch about observability and how it's different than monitoring? Okay, I'm going to back up and cover this base real quick. So observability is kind of the notion beyond monitoring. Like monitoring is kind of the over-encompassing thing about you get metrics, you can look to see what's happened in a system, you can get dashboards, all that kind of jazz about what state the system is in, where it's been, what's been going on, all that kind of jazz. It's usually kind of a post-state review system when you're thinking about monitoring. A lot of it is based around, well, I collected this data of things that happened 10 minutes ago or an hour ago or a day ago, right? Observability is about, is the system alive? Is it doing what I think it's supposed to be doing? Are the credit card transactions processing right now? Like, what is happening? What are my events doing? So observability is a lot more about being able to see that the system is doing what you think it ought to be. Case in point, one of the things that happened at Home Depot, a lot of monitoring was in place. But a lot of the time we'd get flags that said, oh, such and such is down, and this database thing isn't working, and something else isn't working. But then we go to the website and we're like, nope, you can still buy a shed. So then we have to figure out, do we even really have an emergency, right? Nothing is more annoying than spending 6 hours and realizing that the system's recovered, right? That's almost a failure in and of itself. So we started to implement more things around the idea of observability. And when we did that, it saved us a lot, because then we would get more eventing off of are these systems actually communicating to each other? We started looking at things from the perspective even of, can we even have the machine determine these things through algorithms, like machine learning algorithms and things like that. So one of the libraries I have looked at and used a little bit in aid of helping Home Depot and other large companies like this is Veneer. Maybe, I don't know if I got that. Anyway, this is a library for Go that'll help you do pre and post aggregation. So it'll pull time series data and stuff like that, and then kind of do calculations on it so that you can have it in a high cardinal, collected way and be able to get reports off of it really quick and really get insight into something at that point in time versus like, waiting an hour for reports to say, oh, this stuff is broken and the data's corrupted or whatever. It also does trace collection. So like when you have a distributed system, say like Kubernetes, and you got 50 million containers out there and you're trying to get an idea of the state of the overall collective system versus like, you don't care about container X, right? You don't care about container Y. You want to know if the whole thing is working. So that collects all that stuff together. Uses a statsd and a dogstatsd protocol. And right now, it's primarily supported by Stripe. So does everybody know what Stripe is? I don't know if it's that universal. I guess maybe it is. I see it everywhere. It's just the credit card processing with the nice, pretty point-of-sale systems. So that's the main company that uses it that I know of, and the one who kind of does 90% of the open source from what I can tell. But that's a good library. Another company that has libraries and also kind of preaches a lot of observability ideas and such is honeycomb.io. Charity Majors, Christine, Ben, the whole crew at Honeycomb are awesome for that. So if you don't know who any of those individuals are, go look them up on the internets, and you will find tons of stuff. It's great. They got great talks. I love following their stuff. They're always putting together good ideas. But Honeycomb is basically an online service that is your observability as a service provider. One of the libraries they have is Beeline, which helps you instrument your apps. They also have, which I failed to put on this slide and should put there later, another repo that's specifically to helping you get data into their service. So like you could use the instrumentation and not put it in Honeycomb technically. But like I was saying, it's managed. So like if you want something to give you some observability capabilities quickly, sign up with Honeycomb. You get high cardinality data. They got driver support. The team's really great, et cetera. So I love working with them on all of my I need observability right now needs. There's also OpenCensus, which I included here, even though I have used it for all of maybe 5 minutes. But it's a library and an effort to kind of standardize on some things. Not super familiar with it, but I wanted to put it in here out of kind of covering more bases in this regard. And then this last one for this category is RxGo, which is reactive extensions for Go. Who has done reactive programming? Okay. This will probably sound not new for most of you. So reactive programming, quickly thinking of a way to paraphrase this. If you're trying to get good observability and insight into your applications, one very, very effective way to do it is to learn and become familiar with reactive programming practices and build your applications upon that model. Makes it exponentially easier to get observability out of it because the inherent nature of your system now works on things that are observable. That's literally like the name of the thing that you would make be reactive, and then have subscriptions to it. So when things change, you're immediately notified, right? So being that the entire idea and model of the programming style kind of dictates observability from the inception of whatever you start. So added that in here. Not particularly like a library that collects data, but it's a way to program, and Go has its own reactive extensions, just like pretty much everything else, Java, C#, JavaScript, et cetera. So data schema migration. This is one thing I've Googled a lot lately, and I keep telling myself, stop looking up data migration or database migration. You have to put schema in there or you get all the wrong blog entries. Data schema migration is basically being able to roll up a database and pull a database down from nothing to what state it needs to be in, right? The idea is you always keep this kind of versioned tracking of your SQL statements or your CQL statements or your, drawing a blank, the Mongo query statement, create thing, whatever. Anyway, any type of database you have, even if it is schemaless, you should have some type of notion of doing your schema migrations. to know what kind of data you're collecting, what type of things, and have this like versioned history of this process. That way, whether you're using containers or VMs or whatever type of database, you can roll that database up on whim and then tear it down as needed. So you can always start from scratch for like new developers. You can troubleshoot things easier. There's a lot of reasons to do this. I'm a huge advocate that if your project is going to have any type of relation to data, which I think is probably everything, you should have some type of data schema migration practice put into place. I promise you it will save tons of time over time, even though up front it often seems like, why am I doing this? This is taking hours. But once you get it going, it's just like having a CI/CD process where you're like, well, how did I do this if I didn't have this, right? On that note, Golang has Golang Migrate library. Very cool library. I've already started to look at committing some to this library. It has support for Apache Cassandra, Postgres, MySQL, Redis, Mongo, more of them than I have fingers. So it's a really, really great library, and it's a great library even if you're not using Go, because you can just use the CLI, right? You can grab it, build it, or I guess you can just get the binary itself, like I was saying, and just use it for whatever. You can use it in a Java project or whatever. So really, really great library. There is one other library, GoCQLX Migrate. I have to say it slower, or it turns into just a weird sound. So GoCQL is actually the driver for Apache Cassandra built by the community. GoCQLX is some extensions built by SiloDB and the open source community, and it has a bunch of things besides migrate, but it has a migrate specific for Apache Cassandra and the I guess you could call it the forks of that, like SiloDB, which is like the C++ rewritten Apache Cassandra. And it's super helpful because it's built very, very much with the mindset of like, you're doing migrations for a distributed database. This isn't like a box. There's other notions of what's going on that you need to take into account. Quick example, like when you build a key space, which is kind of like a database in Postgres or SQL Server, you build this key space, but this key space needs to be replicated accordingly around to different nodes. Those types of additional little pieces of information often need to be put in your migration, right? So that's another library. So if I didn't say it, schema migrations, definitely do it, learn about it, and like front load it in there with all the other millions of things people tell you to put in all greenfield applications. Sorry to add another one to that list. It's always like, well, just have a finished product immediately when you start. That's what I feel like when people say, here's the thing you have to do at the start of every project. All right, next thing, you have data. You never get it exactly in the state that you want it in always when you want it. So you have to set up pipelines, or you have to extract it from some other system. I think one of my favorites was this, what do they call it? They called it double record database something something, and it was written in COBOL with RPG and on an AS400. Yes, that's it. Whew, that's going back. So on this system, the data had multiple copies of itself within the database, right? So you can probably tell just from that statement where some problems lied. We had to dedupe data, and then we had to figure out, like, was the deduplication all of the deduplication of all the duplicate stuff in the database? Sometimes we just didn't know. And we even had some serious gurus that knew this database, and they're like, well, sometimes it's hard to trace down all of the duplicate data in the system. Only the system actually knows where all the duplicate data is. But it's one of those things you have to do. Hopefully, not many of those exist in that state anymore because they are difficult. So one of the big libraries, and this library, and working with this and reading about it and learning about it, has brought up another thing that I've kind of felt over the last couple of years, but I noted very distinctly recently. ETL has become data science is ETL, and BI, business intelligence. All this stuff that was like the hot words in the 90s are basically new mutations of it, are just data science and machine learning and all that kind of stuff. It all boils down to math. It's awesome. But So pachyderm, that's elephant, by the way. That's what that word actually is. But the software project is pretty cool. It's pretty extensive too. Maybe it's expensive, I don't know. It's extensive too in the sense so much that VCs have actually funded a company around growing this. Pachyderm does a lot of stuff for your data. So it'll help you do extraction, transformation, loading, that kind of stuff. It'll also help you build pipelines. It'll help you version control your data. I love that whole notion, right? It's like Git, but for your data. So that can get tricky sometimes. Like if I have 14 petabytes of data and I need to version it and I'm going to have another 40 petabytes tomorrow, that's a problem. But the endeavor is there to get this version state of your data as you work through things. And that's very important when you get into the reproducibility of results, right? So like when you're doing data science, inherent in the name science, right? You want to be able to make reproducible results from whatever your tests and your experiments are, right? So that's one of the things that this library helps you do. And then data provenance. I'll admit something. I had no idea what provenance mean. I thought it was like a croissant or something, and then I looked it up, and I was like, oh, it's the lineage of data. Okay, why didn't they say that? I don't know, big word. But now I know what provenance is, and I get it. And it's a place in France, too, I know that. But, so, I got to not crack myself up. I'm not supposed to laugh like that. So once you get all that, the reproducibility, you get your versioning of your data, you can look back through the history of what you're doing with your experiments. And part of that is being able to incrementally work on these things. Like you work on a little chunk and you're like, okay, I've confirmed this, now I need to move to the next step. It's almost like integration testing on a large scale with data. And then running these things in parallelization. That's always a little tough because you're like, well, I need X, Y before I need Z, but now I need a workflow pattern, et cetera, those types of things. Pachyderm helps with that in some pretty big ways. Also, a library that I've looked at a lot recently, Reflow, is awesome for helping with that too because it's got a domain-specific language that is, well, it says it on the slide, functional, lazy loading type, and it'll help you step through things and write out that workflow. Right, that you say, I need these things to happen, and then I need this to happen so that everything works and comes together in an appropriate way. And it also does a lot of containery stuff around cluster execution, knowing where these things are, creating them and then tearing them back down, and that kind of stuff. And it also does memoization, another fancy word which basically means I've put data over here that's ready for querying or whatnot already. And Pachyderm does a little bit, but I found myself kind of switching between the libraries, largely because Reflow is kind of more, it's smaller, has less dependencies, and just kind of it seemed a little quicker to get started with some of that. Pachyderm is much more inclusive of a whole lot of problem space, right? It's not just one library repo. Well, I guess it's primarily one repo, but there's a lot of pieces to it. So sometimes it can be a little cumbersome and difficult to get started with. You got to sit down and spend some dedicated time playing with it. And all of these libraries, oops, still on this one. Like I was saying, they've taken a lot of words from the BI ETL space of the 90s and just brought it forward and then added data science and machine learning, et cetera. You can do some of the simplest stuff that you need with it and some of the most complex stuff with it. So even though some of them, like I was saying, Pachyderm requires you to kind of go look at it, but if you're just trying to do one little thing, you can still go grab the library and get started with it in relative quick effort. Like you probably get it started in a day, and then you have that library to handle your ETL or whatever you're doing from then on. So that's handling of the data. And backups. We already have all the solutions for backups. We don't need to talk about that, right? Because they always work. What? No? Yeah, as I write that, I'm like, we have our known solutions, but then the way we implement them it doesn't always work, right? The thing I use is Restic. Lets me use either the CLI, kind of like that migrate library. I can just build or grab the binary itself and just use the binary if I just want to do backups. Or I can put it into code, so that if I'm writing out a process or writing a CLI to manage other multitudes of things and I need a backup process in that CLI tool that I'm doing, I can use RESTIC and add all of its capabilities into my code and not reinvent it. It lets you do things like do incremental backups, time slice backups, all that kind of thing. And it'll also send the backups for you to places like S3 and Amazon, whatever Google Clouds, whatever their blob storage is, and then Azure Blob Storage. That's a pretty good name from Azure on that one. You know exactly what it is. It's the blob storage. And it does some other things like that, to help you go through your various database backups and have a programmatic way to work with that mimics your CLI way to do it. So the other thing, though, that RESTIC is kind of got a good emphasis on, that I'm a big fan of, is years and years ago, I got super, super paranoid that if I make a backup, I just assume that it never works, ever. That's my first assumption. So immediately, the minute I get a backup, the first thing I want to do is restore from it, right? So I'm like, give me an environment, and I'll go restore this thing and see if stuff shows up right. RESTIC has a lot of that built in where it's like, while I'm doing a backup, do my validity check, and also start a restore over here as it streams to the backup, right? So there's ways to kind of verify in multiple steps and get multiple confirmations of the data is verified based on the encryption or whatever that it's going through to be secure, and it also is actually getting out to the place because we just recovered from it in this other container over here. It's confirmed, now the container's nuked, and I'm done. So the fact that it's got like multi-stage verification of restoration after the fact, I love, because it takes care of all my paranoias with relative ease. So that's the backup solution, which we now have solved. And then I wanted to include database drivers, just because without the database drivers, writing a driver is not exactly a small, piddly little thing to do. It's often quite some work. Go has drivers for pretty much every database that you can think of, plus ones that don't even exist, from what I can tell. There's Postgres. It's a common one. Apache Cassandra has GoCQL and GoCQLX. And as I was mentioning, the extensions has the migrate, but it does have other features, so it's kind of nice to use them in conjunction with each other. There is Microsoft SQL Server, which I'm still trying to figure out if Microsoft's actually the one supporting the driver or if it's just community, like random people out there doing it. I can't figure it out because there's now so many people at Microsoft that every time I go out to campus, I get this weird feeling that someday I'm going to hear, so Microsoft created this language Go and this thing Kubernetes, and anyway, I get this weird feeling sometimes. It just seems like they do so much work with Kubernetes and Go, it's almost like they invented it or something, but we know that that's not what happened. But I love the fact that they're doing the work. I pick on them, but there's a lot of good work going on out there. And of course, MySQL, because you got to have like the most common database ever used in existence in your driver support. Pretty much every one of these drivers has a lot of those things that you would expect and want in a driver for the database. They have like paging and connection pooling and all of that. The basic fundamental pieces that you need out of a driver if you're going to write an application against that database. One of the side benefits, of course, is it being written in Go. You have a lot of that immediate ability to know that how it's managing its concurrency. Like if you learn a little bit about Go, you'll know that there's inherent abilities in those drivers about concurrency and Go routines and things like that. So you can kind of reason about how the drivers are actually processing a lot of the stuff they do. Whereas I can say for a fact, if you dive into C#, say, and then you try to reason about how it's the Java driver in C, or not the Java driver, the Java wrapped driver for Apache Cassandra is working, you may not come to the correct conclusion for various reasons. So with Go, they're written purely in Go, and you can use the Go language logic to figure it out. And there's where the complete list is. out on github.com, Golang, Go, Wiki, SQL drivers. And of course, I will make my slide available. Maybe not have to state that, but this and a lot of other links are available also on my blog, compositecode.blog, not .com, it's actually .blog. And it wasn't $500, if anybody's wondering. I paid like $20 for that one. And I don't have a dev domain yet. So, with all that said, we've covered why Go is a good language to use for database engineering, database reliability engineering, and kind of work in general, like when you're building your CLI or even your services or whatnot. A lot of what I do around the database engineering is build CLIs for other people to use to help streamline a flow. And a lot of the time, probably, I'd say 70% of the CLIs I build end up in some CI/CD flow, right? Like it just ends up called, somebody pipes some stuff into it or whatever, they call it and it executes things and then poof, the result occurs. So that's what a lot of these libraries, like that's what I'm using it for. I am kind of assuming, and I think safely, that they're great for other things too, like writing a web application in Go or whatever, because you can do a lot of things in Go now. You can even write a user interface. Don't know if you want to do that, but you can. My working trio, though, of tooling that I always use right off from the beginning of anything that I do on any application, CLI, service, or whatever, is I always do my schema migrations. Even if I don't know what database I'm using, I usually start with these two because I've got it set up where I can do that in like 2 seconds with containers and whatnot. There's another thing that I haven't mentioned that Go has that's super, super, super awesome, and that is Cobra Commander. So this is like I'm trying to think of the Ruby one. There's a commander that helped build CLI applications. This is the same thing, but for Go. Helps you build CLI applications. You get a lot of built-in capability around the skeleton that you can write or you can have generated with the Cobra CLI. So one thing you'll find common, as has been with other libraries, you get a CLI tool with the actual framework and library itself. So you can use it in code, or you can use the CLI, however you want to generate your CLI app to start. You got a lot of different options there. And then Cobra has Viper, which manages your configuration for your CLI app. So it defaults through a flow of like environment variables. Do you have user session environment variables? Do you have it in a YAML or XML or JSON configuration file? A lot of solutions there with a lot of defaults. Again, I love it. I don't have to recreate stuff that I feel like I need to just have already. So Cobra for Go is awesome. Like I said, Viper comes inclusive of that along with a lot of other things. If you know what G.I. Joe is, you'll notice what's going on here with the naming theme. It's pretty great. I watched like 5 minutes of one of the G.I. Joe movies out of inspiration of this, and I was kind of horrified, so I cut that back. But, I mean, Bruce Willis ended up there at some point. I thought I was going to get to that, but whatever. He's got my favorite hairstyle, so I just, I love seeing him in movies. And then, of course, my third of the trio there is I have a set of things, and I'm actually kind of working on this. I don't have it done. I don't have it baked. But I'm working through kind of like a built package, like a starter kit of Go bits around kind of the data side of building a CLI, right? So like you can grab Cobra, you can get your schema migrations going, but then you still need those other bits to do backups, restores, extractions, transformations, all that data science stuff. Like I'm working on building out a thing where I can just roll a solution in like a half a second, and it has all these other libraries and pieces ready for me. So this is kind of like the third part of what I like to start with, which I don't entirely have baked. Part of it is because there's a lot of decisions to make, and I haven't made all of the decisions. So, with that said, that's me. Oh, I wrote all that. That's hilarious. I'm on Twitter. I'm on GitHub. There's my blog. If you search on YouTube, you'll find my channel. I have like 1 billion videos on doing all sorts of stuff. And one of the things that I would love for all of you to join me doing, and we can work on this stuff together, is I go on Twitch all the time now. I'm kind of addicted to it, even though I thought it was the dumbest thing on earth like 3 months ago, but I was very wrong. I go on there and I basically do work on a regular basis, and it's a lot of fun. I talk to everybody. Everybody comes in. They're like, "Oh, I got this idea. You should do this thing for this thing," and da da da. It's very. I will add this. It's not the game community at all. So to note, if anybody knows some of that stuff, it's not that. It's actually constructive. Like, people come in and they're like, "Oh, look, you're doing this thing," and, "Oh, I think your solution is this." So it's very friendly. It's awesome. It's like a little friendly community of people that jump into each other's streams every now and again and help each other get stuff done. It's pretty awesome. But I stream about doing this data project work, Go, a lot of distributed database stuff. Sometimes I do Photoshop. I'm not very good at it, but that's what I do. So if you want to join me on Twitch, that's where I'm at, Adron Hall on Twitch. And that is the information I have for everybody. Thanks for having me. Questions?
With Pachyderm, you were talking about data versioning. Is that the same as bitemporality?
Wait, say that last part of that again.
Does Pachyderm address bitemporality with your data?
I have no idea.
Cool, let's take it offline.
I have to talk to you about that, yeah. Any other questions? Oh, and I listen to heavy metal on my Twitch stream, so it might be bothersome, but it's my Twitch stream, so I think that's it. Thanks.